In this problem, a sample of 100 women is obtained and their heights and pulse rates are measured. The linear correlation coefficient is found to be 0.246, and the equation of the regression line is given as y hat equals 17.7 plus 0.880x, and x is representing height. Then we find out that the mean of those 100 heights is 63.6, and the mean of the 100 pulse rates is 74.4. So the next piece says find the best predicted pulse rate of a woman who is 70 inches tall using a significance level of alpha equals 0.01. What we need to do is figure out if this linear correlation coefficient of 0.0246 is strong enough or not. Well, we need to pop up this critical value table, and remember we want a significance level of 0.01. So we're going to look at the table at 0.01, and we're going to go down to a sample of size 100. We get a 0.256. Our number for our correlation coefficient needs to be stronger than 0.56. We then notice that our correlation coefficient was 0.246, which is not stronger than the 0.256. Which means that we need to use the mean of the 100 pulse rates, which is 74.4. In problem 3, you have a set of data that you're being asked to find a regression line for. If you do not wish to manually type this information in, you can click on the table, say copy to clipboard, and if it's not defaulting to comma, then have it as comma. Select your table. Hit Control-C or whatever command you use for copying. And I would paste this over in our Alcula.com calculator statistics linear regression website we had used before. I'd hit Control-V for paste and go in and remove that first row of XY. Submit our data, and our linear regression equation is then y equals 3.40 plus 0.8x. It asks us to create a scatter plot of the data. We can go back to our website and see that our scatter plot was this parabolic shape of x's. Just choice B. It says identify a characteristic of the data that is ignored by the regression line. Well, our data is not in a straight line, so far choice A looks pretty reasonable. B, there's an influential point that strongly affects the graph of the regression line. No, there is not. There's no outlier. C, there's no trend in the data. There is a trend in the data, it's just not linear. And D, there's no characteristic of the data that is ignored by the regression line. Well, there are characteristics ignored, and that's the fact that this is not linear, so I pick A as my choice. Then this moves on to question 4. In question 4, it says using the pair of values for all 10 points, find the equation of the regression line. After removing the point with the coordinates 1, 3, which is in this bottom left-hand corner, use the pairs of values for the remaining 9 points and find the equation of the regression line. Compare the results from parts A and B. Here we do not have a set of data. We have to create our ordered pairs instead, and then we type them into a website such as the Alcula or Mathway.